Hi all. Today we're going to strictly cover multi-threading within Godot. We're going to start off by creating an example async script in C#. And we're just going to open this very quickly. First off, we're going to start off by vertically aligning because for my methodology, I always do vertical alignment. We're also going to be strongly typed, so we're going to add sealed because nothing's going to be inheriting from this. And we're also going to remove these comments in the system namespace because we're not going to be using them for this guide. However, we are going to be using both ready and process throughout this little guide. But we're also going to analyze the fact that this example script is actually inheriting from Node. Node, as many of you are probably aware, is the base object for which things are created within Godot. So every single one of these in the scene window is a node, whether it's 2D, 3D, a control node, etc. And everything from the node class actually executes within the main thread of Godot, which kind of gives us a little bit of it doesn't give us much control over execution of additional information. Maybe you may have something where you want to process information from a different thread. And so we're going to start off by making a brand new function in this script. This is going to be an asynchronous void function, just simply called start a task. And all this is going to do is simply start a task for us. We're going to make use of the system threading. So we're simply from the main thread, we're actually going to just call start a task at the start of this application. Moving into our start a task function, we're actually just going to make use of tasks.run. This is a system class that exists that we can actually just start executing a separate thread. And we are going to make use of C#'s lambdas here as well. And we're going to use a couple different things here. In order to, the end goal of what we're going to be doing here is we're going to be outputting red text and white text from both process and start a task, which essentially is going to describe that we are essentially executing in two different locations. So we're going to start off by, in our asynchronous task, we're going to start off by, one, making this awaitable, asynchronous as well. So our lambda is now an asynchronous function. And we're going to start off by creating two separate constant variables that we're going to simply do constant start delay in milliseconds equals 500. And a second one, which is going to be output delay in milliseconds. And essentially what we're going to be doing here is we're going to delay our asynchronous function to not start printing out text immediately, so they're not competing. Not that it's really a competition, but we're going to have essentially the information staggered on our output. And in this function, first off, we're going to be awaiting again with another a separate delay. So essentially, for those of you familiar with C++, this is essentially thread sleep. And all this is going to do is we're going to be taking in the start delay in milliseconds, and this is going to stop our this particular task, the initial task, from running for 500 milliseconds, was essentially half a second. And then we're going to move into while true, and we're just going to output information to our console. So all we're going to be doing is doing gd.print gd.print, and we're going to subsequently also delay this by 1 second, so 1000 milliseconds. Same thing we did here, except we're going to be using the output delay. And we're going to make use of C#'s interpolated strings, strictly by doing output from task. And we're going to put in the function name that we're using here. So we're going to use two nameofs. We're going to start off by doing the script we're using, and then we're also going to be using the function just because I like to know exactly where stuff is coming from. Interpolated lets us make good use of renaming our functions without even having to change our strings. So this is all this function is this task is going to be doing. This is going to output the task in white text into our debug output. And in our main thread, we're actually going to make use of simply doing an output too, but we're going to have to add some information here. So we're going to have a private const float because process is working in milliseconds already. 1 second is essentially well, it's using decimal points. It's not using milliseconds as an integer. So we're just going to make a const float seed output delay in seconds equals 1f. And we're going to have a private float elapsed variable where this is strictly just recording information. So we're going to have elapsed plus equals casting our delta as a float because we don't need that much precision. If our elapsed is greater than or equal to our output and delay in seconds, we're just going to reset elapsed back to 0. And we're strictly going to be doing the same thing we did here, except we're going to output this, and instead of white text, we're going to use red text. So we're just going to print out an error. It's not actually an error, but for the sake of arguments, we're going to use red text. And we're also going to change our function name so we know that this is in process. We're going to change this from output from main. Main represents the main thread that this is executing on. So now we're going to have two separate tasks that are both outputting information to our output log. So getting started with the Godot editor, we are just going to create a brand new node. We're going to add this to core. It's not really a core script, but if this was an asynchronous task manager, maybe you have an allocated a task that you can make use of. We're going to add this over here simply for simplicity's sake. I'm going to rename it exactly as the script is, and we're going to attach that script. Save our scene, and simply by running this, we're going to see the red text and the white text from our script. So simply hitting play in the editor, our window has nothing, but you can see from here that we have output from task, output from process. And essentially what this allows us to do is now we can make extensive use by using multi-threading to essentially delegate. While this task isn't particularly impressive, you can start to use this in more complex allocations. Like for example, for those of you that don't know me that well, I stream on Twitch. And a lot of times I'll actually do, I program my own overlay, and so I make it using the Twitch APIs, where I actually have these separate tasks delegated to be able to handle copious amounts of information that's being processed from Twitch windows. You can use this for anything, like maybe you have to create a separate texture or object or whatever, procedural animations. Simply by doing this, you can delegate that information to a separate thread. And we're going to go over in a later video, I'll put the link down below, using these tasks and linking them back to the main thread, because like I said at the beginning of this video, all nodes have to be executed from the main thread. You cannot, I'm going to go over an HTTP manager at some point, where I actually have HTTP calls set off to a separate thread because my Twitch manager actually requires being on a separate thread. So trying to create HTTP tasks requires me to create a brand new output or a brand new node, and those nodes have to be sent off, and they have to be created from the main thread and everything. When you move into multi-threading in Godot, you have to link everything back to the main thread. So at some point I'll go over the idea of linking back nodes to the main thread, and I'll put a link down in the description. So hopefully this helps in your Godot adventures and you make good use of multi-threading, because it's extraordinarily useful. You can even see here that we have our thread is actually going faster than the main thread. So it's very good to make use of multi-threading. So I hope this helps. Cheers, dudes.